Have you ever wondered if we could travel at the speed of light? This idea, known as light speed travel or LST, has long been a captivating notion for many. It's the stuff of science fiction, the dreams of futurists, and the playground for theoretical physicists. Imagine the possibilities: traversing the vast cosmos in the blink of an eye, visiting distant galaxies, or even journeying to the furthest reaches of the observable universe. It's a concept that has permeated our culture and our collective imagination, featuring in countless books, films, and TV shows. But is it purely the realm of fantasy? Or could there be a glimmer of scientific possibility hidden within this idea? Could we one day harness the laws of physics to travel at light speed? Let's take a journey of our own into the realm of possibility and explore the concept of the Higgs distortion drive. The first component of the Higgs distortion drive is the Higgs field modulator. Now, what does this do? Well, imagine if we could make a spacecraft as light as a feather or even lighter. That's the job of the Higgs field modulator. It generates and controls what we call an outer Higgs distortion field. This field manipulates the properties of the Higgs field, a quantum field that gives particles their mass. The modulator uses advanced quantum field technology, a level of tech that's currently beyond our reach, but not our imagination. It's based on the extrapolation of the properties of the Higgs boson, a particle discovered in 2012 that's associated with the Higgs field. By manipulating the Higgs field at a quantum level, the modulator effectively reduces the mass of the spacecraft to zero. Imagine that, a spaceship with no mass, able to move at the speed of light without the constraints of mass-related energy requirements. It's like taking the brakes off a car, but on a cosmic scale. But how would we control such a device? That's where things get even more interesting. The Higgs field modulator would need to be operated with a level of precision and understanding of quantum mechanics that we are yet to achieve. This device generates and controls an outer Higgs distortion field, effectively reducing the spacecraft's mass to zero. It's an exciting concept, isn't it? A true marvel of theoretical technology. Next, we have the quantum entanglement core. This ingenious component of the Higgs distortion drive takes on the crucial role of managing the inner Higgs standard field. Think of it as the guardian of normalcy inside our hypothetical spacecraft. It ensures that despite the outer Higgs field being manipulated to reduce the ship's mass to zero, the standard mass properties within the ship remain unaffected. Now, how does it manage such a feat? Here's where we dive into the realm of quantum mechanics. The quantum entanglement core employs a fascinating phenomenon known as quantum entanglement. This is a process where pairs or groups of particles interact in ways such that the state of each particle cannot be described independently of the state of the other particles, even when the particles are separated by a large distance. In the context of our Higgs distortion drive, this quantum entanglement is utilized to synchronize the ship's internal field with the normal Higgs field. This ensures a stable environment inside the ship, a kind of quantum field synchronization, if you will. Imagine being able to travel at light speed, all while sipping your coffee in the ship's lounge, unaffected by the mind-boggling speeds outside. It's the quantum entanglement core that makes this possible. This core keeps the environment inside the spacecraft normal, despite the outer Higgs field. Powering these two components is the energy source. Now let's imagine what kind of power it would take to manipulate the very fabric of reality. We're not talking about a simple battery here. This isn't your everyday power grid. We need something that transcends our current understanding of energy production. Picture a zero-point energy extractor, pulling limitless power from the vacuum of space itself. Or consider an antimatter reactor, harnessing the enormous energy released when matter meets its opposite. Alternatively, envision a compact fusion generator, replicating the very process that fuels the stars. These are not just the daydreams of a science fiction writer, they're the signposts pointing us towards the future of energy. They're the big, bold ideas that could one day power not just a Higgs distortion drive, but our entire civilization. This energy source must be highly efficient to power the Higgs field modulator and quantum entanglement core. The field transition buffer is a crucial component. Just as a tightrope walker uses a long pole to balance, our hypothetical Higgs distortion drive uses the field transition buffer. It manages the delicate balance between the outer Higgs distortion field and the inner Higgs standard field. This is no mean feat. The balance must be perfect. This buffer is like an invisible safety net, preventing the catastrophic consequences of a misstep. Imagine the buffer as a sophisticated system of field dampeners and regulators, constantly adjusting and maintaining equilibrium. This system delicately dances between the two Higgs fields, ensuring a smooth transition. The theoretical mechanism behind this might involve exotic materials or unknown principles of field dynamics. We're talking about the kind of stuff that would make even the most accomplished physicist's head spin. It's a blend of current understanding and imaginative extrapolation, straddling the line between science and science fiction. This buffer prevents catastrophic effects when switching between the two fields. It's the unsung hero of our light-speed travel dreams. A Higgs distortion drive also needs a navigation and control system. This system is the brain and the navigator of our light-speed spacecraft. Its primary function is to control the trajectory and speed, which, as you can imagine, can be quite a task when you're dealing with the kind of velocities that can outpace light. To achieve this, our navigation and control system needs to be more than just sophisticated. It needs to be superlative. It must be capable of calculating and adjusting the complex field dynamics required for light-speed travel, a task that would be beyond the reach of our most powerful supercomputers today. This is where we introduce the concept of advanced artificial intelligence combined with quantum computing. The AI component is responsible for making real-time decisions, analyzing countless variables, and adjusting the spacecraft's course with precision and speed. Meanwhile, quantum computing brings us the power to process vast amounts of information in the blink of an eye. Imagine a chess grandmaster, but instead of contemplating moves on a chessboard, this AI is contemplating the trajectory and speed of a spacecraft moving at the speed of light. And instead of relying on conventional computing power, it's using the almost mystical processing capabilities of a quantum computer. This combination of advanced AI and quantum computing allows us to create a navigation and control system capable of maneuvering through space at light speed. It's a system that not only keeps the spacecraft on course, but also ensures it can respond to the unexpected. This system allows the spacecraft to navigate through space at light speed. The final components are the structural integrity field and life support systems. In the realm of light speed travel, the structural integrity field plays a crucial role. This system is tasked with maintaining the physical integrity of the spacecraft under the extreme conditions of light-speed travel. Now, how might such a system work? Well, imagine a field that reinforces the molecular structure of the spacecraft. This could potentially be achieved through the use of nanotechnology or advanced materials science. These technologies could create a robust shield around the spacecraft, capable of withstanding the stresses associated with achieving and maintaining light speed. On the other hand, the life support systems are equally important. These systems ensure the survival and safety of the crew and passengers aboard the spacecraft. These aren't your ordinary life support systems, though. In this scenario, we're envisioning advanced systems that operate independently of the Higgs fields. This means that even amidst the complex and demanding processes of light-speed travel, these systems continue to provide a stable and livable environment within the spacecraft. They could control everything from oxygen levels to temperature and even gravity. Just as the heart and lungs are vital to the human body, the structural integrity field and life support systems are essential to a light-speed capable spacecraft. Without them, the journey could be catastrophic. These systems are vital for the survival of the crew and passengers. However, there are several limitations and considerations to light-speed travel. One must not forget the relativistic effects. As we approach the speed of light, time dilation becomes a very real concern. This could result in years or even centuries passing in the outside universe, while only a short time has passed on board the ship. Addressing this might require new theories or even additional systems we've yet to conceive. Navigational challenges present another hurdle. How do you avoid colliding with even the tiniest speck of space dust when you're moving at light speed? Predictive modeling or exotic sensors might be the key here. And let's not forget the elephant in the room, the energy requirements. To distort the Higgs field and maintain it while traveling at light speed would require an incredibly efficient and powerful energy source. This is still a concept that goes beyond our current technological capabilities. Despite these challenges, the possibility of light speed travel continues to captivate our imaginations.